So in the previous video, we were talking about the sum and difference formulas, and we derived a very messy representation of the cosine of alpha minus beta. We were able to derive the formula. So don't worry so much about the derivation. If you understood it, that's great. But if you didn't, that's okay too. So here's where we're actually going to do some sort of application to using these formulas and do what types of problems. So first I want you to go ahead and get rid of this sine of 20 degrees. Let's go ahead and change this to the sine of 75 degrees. Okay, so the whole purpose about doing problems like this is that clearly we can put this in our calculator. The thing is, like in our calculator, sometimes the problems are, or they might give it to us in a decimal form, so we kind of want the exact answer, like what would be the exact answer with square roots and everything. Okay, so here is where the cosine and the sine sum and difference formulas will help out. So notice that sine of 75 degrees is not on the unit circle, so we cannot figure it out. So we want to use maybe these two formulas, well actually just this formula for sine, to try to figure out how can we go ahead and figure out this sine of 75 using two other angles that either the subtraction will give me 75 and the addition will give me, or the addition will give me 75. So here is where you kind of want to look at the unit circle. So here I have an the copy of the unit circle, and since everything's in degrees, I want to be able to look at everything in the degree form. So basically what we want to be able to do is look at combinations of the angles to kind of just figure out how I can get 75 degrees. So the way that I like to do it is that I like to start off with the first quadrant and see if any of these combinations, including 0 and including 90, if any of these combinations will give me 75. Well, the obvious one is if I were to add 30 degrees and 45 degrees, I will get 75 degrees. And I already know what the sine or the cosine of 30 degrees is, and same thing of 45. So using these two angles, I know that these two angles will give me 75, so I'm going to use these two. Okay? So I'm going to start off by going back. And since I'm adding the two angles, I'm going to use the addition of this. Okay, so so this is going to be equal to the sine. Oops, I'm making it a little bit uglier. Let me go ahead and make it a little nicer. So the sine of 30 plus 45. Okay, so that's basically what it is. So sine of 75 and it's going to be equal to the sine of 30 plus 45. So I'm basically decomposing the 75 into two separate things. So what is this going to be equal to? So if you look at the sine of alpha plus beta, let me write down the formula up here so that you guys can see. So we're going to be using sine of alpha plus beta. And based on the formula, that gives me sine alpha cosine beta. Since we're using the plus, we're going to use this plus that's on top of it, plus the cosine of alpha, the sine of beta. Okay. So here, notice that alpha is going to be the first number, and then beta is going to be the second number. So in this case, just by plugging in everything in there, so you're going to get the sine of 30 degrees, then the cosine of 45 degrees, plus the cosine now of 30 degrees, and then the sine of 45 degrees. Okay, so if I were to figure this out, then I will be able to get the sine of 75 degrees. Okay, now the next thing that we got to do is just, we can either look at the unit circle, figure out what the sine of 30 degrees is. Remember that 30 degrees is right here. So remember that here's our x and our y. Our x corresponds with the cosine and the y corresponds with the sine. Okay, so in this case, the sine of 30 degrees is going to be equal to 1/2 times the cosine of 45 degrees is going to be square root of 2/2, plus the cosine of 30 degrees is square root of 3/2, and the sine of 45 degrees is just times square root of 2/2. So this guy is going to give me square root of 2/4 plus square root of 6/4. So if I add this together, you will get square root of 2 plus square root of 6 divided by 4. And you cannot add the square roots because they don't have the same radicands in the inside. So basically, the sine of 75 degrees is going to be equal to the square root of 2 plus the square root of 6 divided by 4. Okay. So now let's look at the next one. So the next one is the cosine of pi over 12. So now in this case, it means that we're going to be using angles that have pi over 12 in there. Okay, now this one, angles that have radians in there. Okay, so something that has a pi. So if we look at the unit circle again, and we look at all the possible radians, well, here the radians are going to be this guys. Okay, pi over 3, pi over 4, and pi over 6. You're going to need also circle that one. Okay, so now what we want to do is we want to see what combination is going to give me pi over 12. Now, pi over 12 is a very small number, okay? It's less than pi over 6. So basically, in order for me to get something that's pi over 12, I would have to subtract two numbers from each other, okay? So here's where you really have to tap into how kind of like the, how do you say it? How the denominators are going to work. How can I get a 12? So one of the things that you can do is you can start subtracting a couple of the numbers until you get pi over 12. Okay. You will see that if I subtract this guy and I subtract this guy, I'm actually going to get pi over 12. If I take pi over 3 minus pi over 4, you can either put this in a calculator, or you can just find the least common denominator, which is going to be 12 in this guy. This is going to be multiplied by 4, so that top guy is going to be 4 pi. The other one's going to be 3 pi, and you'll see that you get pi over 12. So basically, using the subtraction of pi over 3 minus pi over 12, pi over 3 minus pi over 4 gives me pi over 12. So let me go back. So I'm going to use the subtraction, so the cosine of pi over 12 is going to be equal to the cosine of pi over 3 minus pi over 4. Okay, so let's write out, let me make this thinner. Let me write down the formula that we want to use. So we want to use the cosine that's minus, okay? So that means in this next one, we're going to use a plus. So it's going to be the cosine of alpha minus beta is equal to the cosine of alpha, cosine of beta, plus sine alpha, sine beta. Okay. All right, so now let's go ahead and do this. So this guy is just going to be the cosine of pi over 3 times the cosine of pi over 4 plus the sine of pi over 3 sine of pi over 4. Okay, and all we got to do now is just figure out what all of these are. And we know how to do that because we can just use our unit circle. So we're going to start off with the cosine of pi over 3. That's just going to give me 1/2. The cosine of pi over 4 is square root of 2 over 2. The sine of pi over 3 is going to be square root of 3 over 2. Then the sine of pi over 4 is going to be square root of 2 over 2. So it's going to give me square root of 2 over 4 plus the square root of 6 over 2 over 4. And it's going to give me square root of 2 plus square root of 6 divided by 4. Okay, so coincidentally, actually, these two were kind of exactly the same thing. Okay, that doesn't mean you're always going to get the same answer. It just means that you just ended up getting this. Okay. All right, now how would we find the sine of 15 degrees? Okay, so we got to now, since we're in degrees, it might be a little easier. Okay, notice that 15 degrees is a really small number. Okay, so we're probably going to have to subtract two different numbers from each other. So you can see that subtracting the 45 and the 30 might actually be a little bit better. That's what we're going to do. Take the 45 and the 30. So we're going to go back and we're going to use a sine. Since we're subtracting two different things, we said that we're going to take the sine of 45 minus 30. So using at our sum and difference formula, we know that we have to use the formula sine alpha minus beta equals sine alpha. So here we're using the minus. Sine alpha cosine beta, and this minus on the bottom, minus cosine alpha sine beta. So we're going to take the sine of 45 degrees, then the cosine of 30 degrees, minus the cosine of 45 degrees, and the sine of 30 degrees. Okay, so now you can just use your calculator, or you can just use the unit circle. So the sine of 45 degrees will just be square root of 2 over 2. The cosine of 30 degrees, that's just going to be equal to square root of 3 over 2. Minus cosine of 45 degrees, that's going to be square root of 2 over 2. And then the sine of 30 degrees is just going to be 1/2. So this guy's going to give me square root of 6 over 4. And then the other one minus square root of 2 over 4. So it's going to give me square root of 6 minus square root of 2 over 4. Okay, that will be my exact answer. Okay, so now what we're going to do is we're going to do this last problem. Now this problem can be a little tricky, so we have to tap into like what we know about inverses. So notice that inverse functions kind of give you two different angles, or they give you one angle, but notice how you have two different inverses, you're going to have two angles. So I'm going to say that this guy right here is going to be alpha. Okay, and then the other guy, I'm just going to make it equal to beta. Okay, so then it's really easy for me to rewrite this as sine of alpha plus beta. Okay, so if I write it like this, then I can easily write the formula using the sine alpha plus beta. And this is just going to be equal to sine alpha cosine beta plus cosine alpha sine beta. Okay, now the problem here is that we do not know what alpha and beta are. Okay, well, we don't know what the sine alpha and cosine beta is, but we know what alpha and beta is in terms of the inverse functions. So we know that alpha here is equal to cosine inverse of 1/2. So in order to kind of get rid of that, we can just move the cosine over by multiplying by cosine to both sides. So then this will go away, so I'm left with cosine alpha is equal to 1/2. Okay, so here's one of them. And then the other guy is going to be sine beta is equal to sine inverse of 3/5. So applying a sine to both sides, this will go away. I'm left with sine beta equals to 3/5. Okay. Alright, so let's go ahead and write that down. So we know that sine alpha, okay, well, I don't know what sine alpha is, so I'm going to leave it as this. Cosine beta, okay, I also don't know what cosine beta is. Plus cosine alpha, we know what that is, that's just 1/2. And then sine beta, that I know what that is, that's 3/5. Now, how do I find what sine alpha and cosine beta is? Well, if I know what cosine alpha is, I can just draw a triangle. Let me use the correct color. So for alpha, I can draw a triangle. Here's alpha. We know that the cosine is the adjacent over the hypotenuse, so this is just 1 and 2. I can figure out the other one using the Pythagorean Theorem. So 1 squared plus b squared equals 2 squared. So 1 plus b squared equals 4. B squared equals 3. So that means that b is equal to square root of 3. So this guy's going to be square root of 3. Okay, and we can do the same thing with the other guy. So with beta, draw another triangle. So this guy, the sine is going to be the opposite over the hypotenuse. Okay, and now we're going to use Pythagorean Theorem. A squared plus b squared equals c squared. So a squared plus 9 equals 25. A squared equals 16, so that means that a equals 4. Okay, and now based on these triangles, I can try to figure out what the sine alpha is. So sine alpha, so here's a triangle for alpha. Sine alpha will be opposite over the hypotenuse. That's going to be square root of 3 over 2. Cosine beta, okay, cosine is going to be adjacent over the hypotenuse. That's going to be 4/5. This guy's going to be 1/2. Oops. This is going to be 1/2, and this is going to be 3/5. So this is going to give me 4 square root of 3 divided by 10 plus 3 over 10. So if to combine this, it will be 4 square root of 3 over 10. Oops. 4 square root of 3 plus 3 divided by 10. So that's everything all combined. Okay, so this one just involved a little bit more of what we've learned from the previous chapter, which you already need to know how to do. Then applying the sum and difference formulas, and then being able to do a triangle to figure out the other missing angles.